Hello again, Professor. Now I'm going to show you how the second exercise of the homework was made. First of all, here I have a group of forces. I have F1, F2, and F3, and of course I got my FR, which is unknown. FR is going to be found when I do the symmetry of all these forces. I don't know my F1, and also I don't know this angle. So, but the problem asks us this angle to be the minimum as possible. So with this information I know for sure that my angle is going to be 90 degrees because it asks us to be the minimum, which means it goes straight for him, which is going to be like a line, a line sign. It depends. It can be in this axis or this y-axis, but we are going to use the y-axis because I think it's more easy to work with in the exercise. Okay, so to represent my angles, I got these triangles which using the sin law I can get my, well, both of them are right angle triangles, so it makes me easier to know their angles. So for example, here I know that this angle is 90 degrees, and I know that this my hypotenuse divided by the sin of the right angle is going to be equal to any of the angles divided by any of the sides divided by the sin of the opposite angle they they have. For example, here I have my hypotenuse and this it's going to be their opposite angle. Here I've got my 3 and I have that this one is going to be their opposite angle, and here I have my 4 and it's here this one is going to be their opposite angle. Okay, so with that said, let's begin with the problem. Okay, so first of all I'm going to find the angles which I'm working with. So to begin this problem I'm going to solve for this angle over here. Actually in my procedure I think I overdid a step. I could say one step, but well, never mind. Okay, so 5 divided by sin of 90 is going to be equal to 3 divided by sin of x, which is going to be this angle, which I'm looking for. Okay, so now I can solve it for x, which is going to be equal to sin of x equal to 3 divided by 5. Here I have my problem, so it's more easy to look at. Okay, what I'm going to do basically is going to move my sin of x here, and my 5 is going to move over here, which I'm going to get sin of x divided by 1, which is going to be sin of x, is going to be equal to 3 divided by 5. Now with that, I can use the inverse of sin in order to get my x, which is going to be equal to sin divided to the power of minus 1 multiplied by 3 divided by 5 is going to be equal to my x. It's going to be equal to 36.87 degrees. Now in order to get the angle that I want, I'm going to subtract it to 360 degrees, which is the whole circle. And by subtracting that angle, I'm going to get this, this angle over here, which is going to be 323 degrees, 323.13 degrees, sorry. Now I'm going to do the same thing with my third force, which I'm going to apply. 13 divided by sin of 19 is going to be equal to 12 divided by sin of 19, which is going to get me sin of x is going to be equal to 12 divided by 13, which is going to, then I'm going to use the inverse of this to get my angle, which is going to be 67.38 degrees. And now I'm working with all this this angle from the 0 to here, which is going to be, well, the summatory of 180 plus what I got of my angle, which is going to be 67.38, which is going to give me an angle of 247.38 degrees. Okay, here I got my angle represented, which is still known here. To continue, here I have my force of 300 pounds, which is going to be multiplied by cos of my angle that I got. It's going to be equal to 240, which is going to be the equivalent of the X force being applied to this. Well, the force being applied in the cos of in the axis of X. Sorry. Then I'm going to do the same with my third force, which is going to be 260 pounds, multiplied by the cos of 247.38, which is going to be equal to minus 100, of course, because it's in the fourth quadrant, which is negative, negative. Okay, so also my white value for this force is going to be negative, which is represented by negative here. Okay, well, now I'm going to pass to the white components of the force. So here I have my second force, which is going to be equal to 300 multiplied by sin of my angle is going to be equal to minus 180, which, yeah, it's negative, it's in the third quadrant. And now I have here my force of my component of white on the third force, which is the force itself is 260. Now I'm going to get the value for white. I have 260 equal 260 multiplied by the sin of 247.38 is going to be equal to minus 240. Yeah, I already did all the operations. Okay, now in order to solve for FR and for F1, I want you to think in this. Here I got my force in X, but since it's alongside the X axis, it's not going to be any force in the Y. And since my F1 it's alongside the Y axis, it's not going to be a force in the X axis. Okay, that makes the problem way too easier for us to solve. Okay, so I'm going to do the summatory of all the forces. So here I have my 200. I'm going to start with the summatory alongside the x axis. Okay, so I have 240 plus minus 100 plus f cos of 90, which is going to be cos of 90 is going to be 0, and well, it's going to be multiplied by the force, which in that case any value times 0 is going to be 0, so I don't have to worry about this. So I'm going to get that all the summatory it's going to be equal to my frx, which is going to be my force in x, and since I only have one, which is in x, and I don't have in y, my force is going to be equal to the summatory of these two, which is going to be 130. Now, to solve for f1, well, I know that I'm going to do the summatory in the y-axis, so I got here minus 180 plus minus 240, it's going to be, plus f1 sin of 90. Sin of 90, I know that it's going to be 1, so it's going to be minus 100 minus 240 is going to be equal to minus f1, because I'm going to move it over here, and since here it don't has a value, it's going to be 0. So yeah, it moves here with negative sign, and it's going to be, I'm going to do this method here, well, this subtraction, and it's going to be equal to minus 420, since they both of them had negative sign. I'm just going to transform it to positive, and it's going to be equal to F1 is equal to 420 newtons. That's all for this problem. I hope you enjoyed this video. Thank you, Professor.